Let us discuss about the viscosity, Newton's formula for viscous force and the variation of the viscosity. The property by which an internal opposing force comes into play when there is a relative motion between the layers of a fluid is called as the viscosity. So, the viscosity is defined as fluid friction. The fluid friction comes into play, or viscosity comes into play, when there is a relative motion between the layers of a fluid. That means when a fluid is in motion, its layers have got different velocities. The topmost layer has got the most velocity and the lowermost layer has got the minimum velocity. So there is velocity gradient, or there is change in velocity between the layers. Fluids have both got the viscosity, but liquids are more viscous than gases. The viscosity arises due to intermolecular forces between the layers of a fluid moving with different velocities. Now, let us discuss the Newton's formula for viscous force. The Newton's formula states that the viscous force is directly proportional to the area of the layers and directly proportional to the velocity gradient. Velocity gradient is rate of change of velocity with distance. Now, if F is the viscous force, as per Newton's formula, F is directly proportional to A, that is area of the layers. F is directly proportional to minus delta V by delta X. Delta V by delta X is the velocity gradient. Rate of change of velocity with distance. Why the negative sign? Because the viscous force is opposing the relative motion. It is opposite to the motion of the fluid, so the negative sign. Combining these two, we get F is directly proportional to minus A delta V by delta X. This is the proportionality sign. In order to eliminate this proportionality sign, we have to introduce constant of proportionality, and that is coefficient of viscosity. F is minus neta A delta V by delta X, where neta is the coefficient of viscosity, and that coefficient of viscosity is different for different fluids. Now, if A is 1 meter square and delta V by delta X is equal to 1 units, in that case, F is equal to minus neta. The coefficient of viscosity can be defined as a tangential force required to maintain unit velocity gradient between a layer of unit area. Now, the units of coefficient of viscosity are Newton seconds per meter square, or Pascal second, or decapoise. Let us discuss about the variation of viscosity of fluids with temperature and pressure. When we take the case of liquids, the viscosity of liquids decreases with increase in temperature. That is, if Nt is the coefficient of viscosity at a temperature T, and N0 is the coefficient of viscosity at temperature 0 degree Celsius, the relation between Nt and N0 is Nt is equal to N0 divided by 1 plus alpha T plus beta T square. That means when we increase the temperature, the coefficient of the viscosity decreases. That means the viscosity of liquids decreases with increase in temperature. When we take the case of the gases, the coefficient of the viscosity is directly proportional to root of the temperature. That means when we increase the temperature, the coefficient of the viscosity of the gases increases. That means the viscosity of the gases increases with increase in temperature. So, revising it a little, the viscosity of the liquids decreases with increase in temperature, and the viscosity of the gases increases with increase in temperature, because the coefficient of viscosity has got inverse relationship with the temperature when we talk of the liquids, and when we talk of the gases, there is direct proportionality. Talking of the variation of viscosity with pressure, with increase in pressure, the viscosity of the liquids increases, but the viscosity of water decreases. Listen one more time. With the increase in pressure, the viscosity of the liquids increases, but the viscosity of the water decreases. And when we talk of gases, there is no influence of increase in pressure on the viscosity. So when we change the pressure of a gas, its viscosity neither increases nor decreases. It doesn't change with the pressure. Thank you.